So here we continue with the test 1 review for Math 210, starting with question 11. And so let's take a look at this one. Now, first of all, we're looking at a limit coming from the left. That's going this way towards -1. So coming from the left, be negative, like just a little more -1. -1.1 is to the left, -1.01. Coming from the left, we're getting closer and closer to -1 in this way. So when we consider this algebraically, if we put in a number in here, one of these numbers, we're a little bit large, we're -1, but a little bit larger than -1, so when you add 1 to it, what ends up happening is your denominator is getting closer from the negative. It's getting something like this, right? And getting closer and closer to 0, but it's got a negative. So what's happening at the top then? Okay, so you put in -1.1, 1 point whatever, you square it, it's going to be positive 1 point something. You're going to add 4 to it, so it's going to be 5 point something. So you end up with 5, something close to 5.0001 if you want. So it's a constant, and we end up with a constant over 0, but we're coming from the negative side, so a positive over a negative, it's going to go to -infinity. So you put in -infinity. -infinity is considered to be diverging. The limit does not exist because it diverges, so we would put that in. The answer it will also accept is D and E at this point because it goes to infinity. Now it would not accept just -infinity. It would not accept just infinity because that would imply positive infinity. You need to have the negative there. Okay. Now if it was coming from the right, we would be approaching it at something like 0.9. So we're getting close to -1 from that side. So we would be getting close to 1 at say -0.99999. So we're getting closer and closer to -1 from this side, which is a little bit less, so it would give you actually a positive in the bottom. So on the right hand side, we would have had going to positive infinity. Okay, so what ends up happening at -1, on the left side coming from here, we shoot down to -infinity. On the other side, we shoot up to positive infinity. So the limit does not exist. Okay. 12. Calculate the average rate of change of the given function. So we've got 2 points, a 6 and a 10. Those are x values. So I've got a point at 6 comma something and 10 comma something. And that something is the function value at 6 here, and this is the function value at 10 here. So we need to plug into this function here. We need to find what is f of 6. Well, f of 6 is 3 times 6 squared minus 6 over 2. I guess we can do this, it's not too bad. 36 times 3 minus 6 over 2 is 3. 6, that's 36 times 3. Let's just go ahead and do it. 6 times 3 is 18, carry the 1, 9, 10. 108 minus 3, it's 105. So we've got 1 point at 6 comma 105. Plug in 10, and what is f of 10? Is 310 squared minus 10 over 2. That's 100. 100 times 3 is 300. 10 over 2 is 5. So that's 295. So our other point is 10 comma 295. We use the slope formula, average rate of change, that's all it is. So we go 295 minus 105. y2 minus y1. And then we do 10 x2 minus x1 minus 6. So we get 4. Up here we get 190. 190 divided by 4. 2 goes into both of these. That makes that 50, 45, 95 halves. So you could put that in there. Or you're going to get, is that 47.5? I think so. Here we go, 47.5. So it's not a repeating decimal or anything, so we should be just fine. Okay, so 95 over 2, 47.5. Either one. Good. Let's keep moving on this one. So we've got this table that shows us some data starting, T is years since 2008, so 2008, 9, 10, so forth. Production. Use the data in the table to compute the average rate of change of S&T over the period 2008 to 2013. So it's 2008, 9, 10, 11, 12, 13. So it's 2013 there, it's 2008 there. So the 2 points are the 2 endpoints. So we have 1.0, 2.25, another 0.5, 1.80, and we can subtract these two. So if you just subtract this way, we get negative 5 here, negative 5, not negative 6. Subtracting 1.25, 1.80 from 1.25, so we get a 5. 8 from 12 is 4, and then 1 from 1, so 0.45. Take this, tuck it underneath, so it's 0.45 divided by negative 5. It's going to give us a negative, and we can see it's dropping, so we kind of expect it's negative. So we want to put negative and 0.45 divided by 5. Is that going to be 0.9, 0.09 maybe? 0.09. Interpret the results. So during this period, daily imports from the country were decreasing. Certainly that's true. They were not increasing, they were not constant. They're decreasing by this amount, negative 0.09. Which of the following is true? Okay. The 2-year average of change of offshore crude production of the country increased value. The 2-year average. 2-year average, 2-year average, 2-year average of let's see what's happening. It's decreasing, it's decreasing, it's decreasing, and then it gets constant, so let's see if they have that choice. Decreased in value, increased in value, then decreased in value. No. Created crude oil production for the country increased in value. No. The 2-year average change offshore crude oil for the country decreased, then increased in value. No, just decreased. I don't know why they're saying a 2-year average, but it's a 5-year average. Anyway, it's just decreasing, I guess. It gets to a constant, but if we look from 2008 to 2013, that is a decrease. I'm not sure what that 2-year thing is. So we just keep moving forward. Okay. 14. Here we go. Following graph shows the approximate number of thousands of people who are immigrating from Ireland. I think we may have done something very similar. During which 2-year interval was the magnitude of the average rate of change of ET greatest? So when's this going to have? So what we're doing is we're looking for these year periods, sort of which line has the steepest slope. Well, this is a decrease here, so that would be negative. I would say it's steepest right here from 0 to 1, which represents 2010 to 2011. So then, oh, that's not a choice. 2000. So we're going from 2010 to 2012. That's pretty steep too. It's steeper than this one. 2011 to 2013 is sort of leveling off. This one is, so I'm going to go with this one. And certainly 2012 to 2014, it's kind of a decrease. Interpret your answer by referring to the rate of change. During the 2-year period, intervals with the greatest magnitude immigrated from Ireland was increasing at an average rate of what? People per year. So then, now that we've chosen this, we go and actually calculate it. So 0, we get 2 points. 0, 69, 1, 81. And again, I've shown this. We can just subtract them, so we get a -1 here by subtracting, and we're going to get a negative number here. 69 from 81 is 12, -12. And then you take the -1 is the x values, tuck it underneath. -12 divided by -1 should give us a +12. Yeah. So we put that right here. During which 2-year interval was the magnitude of the average rate of change the least? So the least would be the certainly 2012 2014, because I see that's negative. We can see a decrease during that time period. So that's going to be the least. Least magnitude immigration from Ireland was decreasing. Now when they say decreasing, we know it's decreasing. We don't put the negative on there. So when we do the calculation, and you can see it's going to be year 2 and 87, and then year 4 and 82. You can just subtract the x's, that gives us -2. Subtract the y's, that gives us actually a +5, and then divide by the -2. That gives us a decrease of 2.5. And again, that's in what, millions of people, or oh wait, this is in people per year. This is in thousands of people per year, so be careful here. I would have gotten this wrong, that's why we check it. This is, the units are people per year. The units for our graph here are in thousands of people per year. So when backing up for the A part, we should have taken 12 times 1,000. So we'll get 12,000 people. So it's increasing at 12,000 people per year. Down here we get that it's going to be decreasing this amount times 1,000. Yeah, 2.5 people. No, 2,500 people per year. And the decreasing's there, so I don't want to put a negative. It'll get marked wrong if I do. So decreasing takes care of the negative. Awesome. Okay, let's keep plugging away. I remember doing this one in class, but so you can look at the graph says at which label points the slope of the tangent line is greatest and least. So since it's at -7 is less than 1. So again, Let's change our pen to red, variety. So looking to draw tangent lines, the slope of the tangent line here through P would be something like that. So a slope of about 0, probably exactly 0. Q, we're looking at, let's see if we can draw that one fairly accurate. It's going to go like that, and R is going to be a line, a tangent line kind of going like that, sort of. Not a real good draw here, but which one's going to be the steepest? This one here, it's going down the fastest. It's going to be the most negative. So I would put the least would be Q, because it's going to be the largest negative, which makes it the smallest. The greatest would be P, in that it's equal to 0. Okay, the slope of the tangent line is equal to 0. Okay, so we can compare those, but you just have to kind of see which one's going to be more steep. So then we've got this graph. The average rate of change of f over the interval 72 to 144 is 72 to 144. We've got this, so that's the average rate of change is greater than f, the derivative at 72. So the derivative at 72, yeah, I would say that looks like an inflection point, so I would say the tangent line actually cuts through it like that, so it would be 0, whereas the average rate of change for these 2 points is going to connect like that. So definitely it's a positive slope, it's bigger than 0, so I would say, yeah, definitely greater than the derivative of f of 2, or f of 72, the derivative. F prime at 72. The average rate of change of f over the interval negative 36 to 36. So negative 36 here, we get this. To positive 36 here, we get that. So there's a slope, pretty steep. Again, just looking at that. Is it great? So now we're comparing for the derivative when x is 0. So when x is 0, there's our slope right there, and that's going to be, that looks pretty close. And the other thing we're looking at is, remember the balanced difference equation. So we went 36 units to the left, 36 units to the right, and that typically gets us very close to being equal. Now, not when we're that far away, but as we get closer, it gets very close to the slope of the tangent line at the point halfway between there, is what it really says. So I would say, yeah, it's approximately as much as we could tell. I would go with that one. Over the interval 0 to 72, the instantaneous rate of change is, now this one they actually want us to change from 0 to 72. We actually need to calculate that. Okay, so we've got the point 0, looks like negative 36, and then we've got the point x is 72, y is 0. So that one we can do, subtract the 2, so we get negative 72, subtract 0, we still got negative 36, so we get, take the x, tuck it underneath the y, and again you can use the y equals mx plus b as well. This is going to reduce, 6 goes into both of these, is that right? 72, 6 goes into 72 divided by 6, is that right? Well, certainly 2 goes into both, I could just do that, but 12, yeah, I thought it did, but I was getting, so this is 12, so 6 goes into both of these, this reduces down to, so divide out 6 here, divide out 6 here, we get 6 over 12, actually 12 goes into both of these, right? Alright, so 6 goes into both of these, so I get 1 half, yeah, that makes sense, and it's going to be positive. Okay, so that's our slope there. interval, the instantaneous rate of change of f. This is wanting the instantaneous rate of change, so it didn't want us to actually calculate it. Sometimes you get in a hurry and you stop to read questions and it takes you longer. So what's happening from 0 to 72? So these slopes of the tangent lines, they're getting less, so they're decreasing. The slopes are decreasing. Okay, so now we're back here. So the slopes are decreasing. Over the interval 0 to 144, the instant rate of change is, well, we see that the first part was decreasing, and then because it's the, so it's decreasing first along here, and then they start, it goes to 0, and then they start getting steeper, so they're going to increase, decreasing, then increasing. Just drawing tangent lines along the way and just seeing what they're doing. They were decreasing, then increasing. And then the last question is, when x is 144, f of x is, so this is the function value. So we're looking at the function value is actually 36, right? And then it's increasing. When x equals 144, f of x is, well, I guess we're going to have to say 25.2, because that's, sure looks like 36 to me, but okay, we'll go with their 25.2, 144, and increasing at a rate of about 1 unit per unit of x, about 10 units. So is it really steep, or is it going up about 1? I'm going to increasing a rate of about 10 units per x. Oops, I don't know, that's maybe too steep. Let's see. So it's going here. Let's see. I would say it's about 1 to 1. Yeah. Actually, I think so. I'm going to choose the one above it. It's not quite 10 to 1. 10 to 1 is so a slope of about 1, not 10 to 1. Okay. Let's get to 17 and see if I can get to 20 before I take my next break. We've given a graph of this function. For which x in the range shown is the function increasing. So we're increasing until we get to here, then we're decreasing. So from here to here we're increasing. Then from here to here we're increasing. For which x is the function decreasing? And then of course decreasing in these other ones. So I go from -2, function is increasing for -2 to x until -1, and then again from 0 to +1, 0 to +1, it's decreasing from -1 to x equals 0, and then from 1 until 2. So it's decreasing. We would have decreasing here, decreasing here. So those are the boundaries. I think that's all they ended up asking. Yeah, that's it. This one on prism populations, I won't drone on about it, but you know what I mean, you know what I feel about these kind of questions. The following curve is a model of a certain country's total prism population for a function t years, so it's increasing, which is correct. Over the period 5 to 10 years, the instantaneous rate of change of n is increasing. So from 5 to 10, it's actually slowing down if you were to draw these. So it's the period, the instantaneous rate of change of n is decreasing. So looking at all the different tangent lines we could draw from between 5 and 10, they're gonna decrease. Okay. Now the rate is, I mean the number of persons in prison is increasing. However, the rate of change is actually decreasing. So which is correct? The instantaneous rate of change of prison populations at t equals 4 was less than the average rate of change of the interval from 0 to 10. So they're going to compare to t equals 4 here. 0 to 10, it looks about equal, you know. And again, because we're going from 0 to 10, we here's this one, here's this one. If we were to draw the line, and we were to draw this tangent line, let's see if we could do this. And again, it's hard to do on a test because you don't have these, but we've got this one, and then we've got to kind of, what would this tangent line? Actually, the tangent line appears to be a little bit more steep, so that would give a greater. So we would say it was greater. They're not equal. Certainly it would be greater, the instantaneous rate of change. If we were at 5, I would assume that they'd be kind of close to being equal, because again, you got that balance thing going on. But at 4, they're not. Over the period 0 to 10, the instantaneous rate of change of n is increasing, then decreasing. So okay, so yeah, so here the instantaneous rate of change, because it's concave up, we would see that the tangent lines get steeper and steeper until they get to the inflection point, and then they start getting less. So the instantaneous rate of change is actually getting faster and then slower, increasing and then decreasing. I would go with that. Yeah. According to the model, this country's total prison population was increasing fastest around what year? So fastest, probably keep doing it up until about 4. Again, it's an inflection point, but see what the choices they give us. They don't really give us choices up until about the year 4, but year 4 would be 1995 plus 4, right? So I would go with this, because that looks like an inflection point. So that'd be 1999. Then roughly estimate the instantaneous rate of form change at t equals 4 using the balanced difference quotient with 1.5. And again, I think we did this. So we're going to subtract 1.5 from 4, so that would take us to 3. That would take us to 2.5. We'll look up that value, and then we'll add 1.5, so that's going to go to 5.5. And let's see what kind of y values we get to calculate this. Again, I'm pretty sure we calculated this in class. So it's going to be about there, and 2.5 gets us there, so that's 1.45. So we're at 2.5, 1.45, we're at 5.5, and 1.55. So they had to give us some nice points here. We subtract 1 point from the other, so 2.5 minus 5.5, that's going to be subtracting 3, a negative 3, and this one gives us a negative 0.1. So you take this, put it in the bottom, we should get a positive slope, negative 0.1 divided by negative 3. So negative is going to be positive, so we don't have to worry about, but it's 1, clear, 0.1 divided by 3 gives us 0.0333. And then we multiply that number times 1,000,000, right? Because this is in millions of prisoners. So, wait, million prisoners per year. So yeah, we don't have to. If it was prisoners per year, we'd multiply by 1,000,000. 3 decimal places. That's good. 1990, this country's total prison population was increasing. And see, they gave us the answer. They wanted it to be 4. We're increasing at approximately. Now this one they changed prisoners per year, so we do have to multiply that times the million. So it's kind of back and forth. So I take that times 1,000,000, which is 1 with 6 zeros. 1, 2, 3, 4, 5, 6. So that's about 33,333 prisoners per year. All right.